These millennial elves, they've been hanging out in college, not learning any skills, drinking too much eggnog. They're unmotivated. They don't work like the elves of the 50s. Nobody knows how to use a hammer anymore. Large planes.
Propeller plane, Lockheed Martin, America. All right. This is getting uncomfortably close to us getting canceled, is what this is doing. Anyway.
It's usually your job.
Shut up. Anyway. Looking very dapper today, Eddie.
As are you, Tyler.
I like your hats.
Hats
are good. Yeah. Get this little dangly thing on my head here.
A little bit.
Yep. Mm-hmm. It's kind of getting in my way. For those on audio, we're dressed to the nines.
Yeah. Merry Christmas,
as the kids say.
Filthy animal.
You filthy animal. Dressed up in our cheerful garb, ready to dive into this topic. This is a very serious matter, okay? We've been tasked, all right? We had somebody shoot us a message in our DMs on Instafaces, and he needs a little bit of help, all right? You might have heard of him. He goes by Old Saint Nicholas.
The real Santa Claus.
The real Santa Claus.
It's the account.
That's the account, at The Real Santa Claus. So apparently Amazon's really putting some pressure on Santa this year. He needs to expand.
Delivery times have to come down.
They have to come down. All right. So he's looking at building a branch in the South Pole.
Yeah.
Okay, he's got his North Pole operation, but he also has his South Pole operation. Stop looking at me like that.
Trying to do this episode in all seriousness is going to be a chore.
What does our life come to? So anyway.
I'm not going to answer that.
No, don't do that. Don't do that. Anyway, so Santa's just trying to keep up with Amazon, right? Toys need to be delivered. They need to... This 2-day shipping thing, it's killing them.
It's killing
right?
Santa.
It's killing Santa.
Got to be able to serve both hemispheres.
Yeah. His doctor told him that he needs to build another location in the South Pole. Yeah. Right? It's a heart condition. All right? Too much eggnog, too many cookies, so on and so forth. So today we're going to really try to help Santa out and go through the logistics of what it's going to take him to actually build a distribution facility rather, in the South Pole.
In the South Pole. Yeah. Okay. What if you were to build a distribution warehouse in the South Pole?
I feel we have good, solid, factual research behind us, thanks to Lee, to help us do just that today.
What we are doing to Lee's research presently is...
butchering it.
A travesty, really.
Butchering it with a knife. And I hope he enjoys it.
We're using the Amundsen-Scott South Pole Station as a template, just in case you were wondering, haven't actually turned this off, and just stop.
I can't. It's in my ear, man. I wonder if I could put a microphone right here.
I've seen it done.
Santa Claus?
Yeah, I've seen it done.
Anyway, okay.
So the Amundsen-Scott South Pole Station is our template
for this.
So there is a little bit of reality that we're...
That's right. We actually did math, and we used our heads for this, guys. This is great. So
this is going to be...
This is epic. All right, so
value add.
Let's get into the South Pole facts first and foremost. Let's kind of set the stage. So at the location that Santa wants to build his South Pole distribution facility, there's an ice sheet, a sheet of ice, 2,700 meters thick. Yeah, that's right, 9,000 feet thick.
I don't know that it's a sheet anymore at that point. It's a slab.
It is more than a slab.
Continent.
It's a continent, yes. It's part of the crust of the earth. And the temperatures in that area are from negative 117 degrees to a positive 7 degrees. But the average in this part of the world is a negative 56. So a little bit cold. Also, the sheet continent thing, whatever we're calling it, it drifts. It's about 10 meters or 33 feet per year. So there's going to be a little bit of shifting that's happening at this distribution warehouse, which we're going to need to take into account.
You think about that. I mean, like that would be this building going 30 feet down the road.
Yeah, that's pretty trippy.
In the period of time that we've been here, like this building would be beyond the hardware store down the street. Like we might be sitting at the end of the block.
I mean, they've got a pretty nice spot down there. So I mean, I wouldn't mind.
Well, you'd still be sitting in this building. You'd just be down there.
Yeah, but you'd be closer to Blackbird unless Blackbird moved.
It would also move because it all shifts.
Well, that stinks.
Well, anyway. I mean, some unique challenges building
definitely
in the South Pole, but it has been done.
It has.
So,
all right. So how much is this going to take? So we need to figure out the cost for Santa to build this whole thing. Yeah?
Okay, so I'm projecting this cost off of a $175 million build cost.
Of course, yes.
From 65,000 square foot Amundsen-Scott.
When did that build stop to?
Okay,
that's another thing. Because we do need to factor in some inflation in this, yeah?
I don't know that this has any inflation. This does not have any inflation factored in. So I'm going to say you need to probably, Santa.
Definitely add a couple billion.
Add a
billion.
Add a billion.
Just to be sure.
Just add a billion.
You're in a lucrative business. You've been around for a long time. We know you got it.
Your average distribution warehouse for Amazon, you said, was around 800,000 square feet?
Around 800,000. I would say that they're starting to get more north of that. But
okay, so we'll just go with that.
We'll go with 800,000.
Yeah, I mean, Santa, you got to at least do what Amazon did. But you're looking at around $2,700 per square foot to build.
I mean, I feel that's completely reasonable, honestly.
So about, 2.14 billion, but we just said add a billion.
Add a billion.
Let's just go 3.12.
No. We got to go with pi here. 3.14.
Okay, 3.14.
3.14. We'll just round it to there.
Yeah, all right. We'll go 3.14 billion dollars to do this build.
Insert Dr. Evil look here. Billion.
This is absolutely based in current reality.
Definitely.
So we have a labor force problem, Tyler.
Yeah, we do have a labor force problem. So we need to figure out how to motivate the elves. Yeah.
Well, these millennial elves, they've been hanging out in college, not learning any skills, drinking too much eggnog. And just they're unmotivated. They don't work like the elves of the 50s. Nobody knows how to use a hammer anymore. Can't drive a peg. The elves of today are a problem for tomorrow.
This is true.
And this is not work for the lighthearted because you can only work 15 minutes at a time if you're a human. Mm-hmm. So, I mean, the shifts for Amundsen-Scott, they'd bring them down there. They'd work 15 minutes at a time.
15 minutes, yeah.
But the elves, I mean, they're a little more, they are resilient in comparison to humans.
I mean, I feel if they're used to the North Pole, they would be relatively used to the South. Yeah, that's a transferable skill, yes?
Absolutely. And Tyler, and much like all of my knowledge of time travel comes from Back to the Future.
Obviously. Why would it not?
My knowledge of elves comes from, well, maybe some Tolkien, but also Christmas movies, especially Elf.
Obviously. That is the most accurate elf movie. Elf documentary, really.
It's an elf documentary.
It's a documentary.
It's got Bob Hope in it.
It does.
Yeah. So
that wasn't Bob Hope.
It's got, No.
Bob Newhart.
Yeah, geez.
Dude.
That's a valuable slip though.
Put because $1 in the jar, man. Like that's ridiculous. How dare you mix those two up? Those two are both icons.
Maybe it's over half a century ago.
So, I mean, let's say the elves can work 20 minutes because they're a little more hardy. Yeah.
Give them 30.
30?
Double down,
We're
man.
doubling it?
Yeah. Okay. But not an hour because they are millennial elves. They work almost as long as millennial humans per hour.
Solid burn. I'll take it.
But
All right.
they do work a little better if you give them some candy canes
And hot chocolate.
and
yeah.
hot chocolate.
Of course.
So,
yeah.
Incentivizing the workforce is something that you have to do.
Well, I mean, that was definitely something that we've seen historically happen. Yeah.
Yeah.
Is that we had to incentivize people to go down to the South Pole to actually work in these elements. They would only be out there 15 minutes at a time. And there's only 110 days per year that they could actually work on this building if we're looking at the historical facts here, right?
Yeah,
not in our land of
we need to stay away from the fictitious in this episode and
sunshine and craziness.
stick to the facts, really, because this is
It's true.
completely and insanely serious. Also,
Santa needs our help.
he does.
He does. We're working on it.
It's-
Okay.
You know what the big day's coming? The big day. That's what people in the business call it. The big day.
The big day.
Yeah. It's when delivery day happens. It's like the Amazon Prime of all Amazon Primes.
Okay.
We don't like Amazon. We like Santa.
No.
I don't mind Amazon. I mean,
Big. Ooh. Hey. Ooh. Whoa, dude. You signed an NDA. All right. You can't say that you like that. Anyway.
okay.
Moving on.
Fine.
Moving on.
All right.
All right. So
Hey, just quickly though, should we think about this? Because, I mean, the millennials demanded ping pong tables and PS4s in their office, but then ultimately just wanted to go home to work where they would eventually not work at all.
So
and
there's
then require the boomers to just drag them back to the office.
easy. All right. So there's some infrastructure that we're going to need to put in place.
You don't like this is getting uncomfortably close to like really.
This is getting uncomfortably close to us getting canceled is what this is doing. Anyway.
It's usually your job.
Shut up. Anyway, so we need some basic infrastructure for the elves. Yeah, we need some housing. We need fuel, gas. Yeah.
You know what? You're in luck. Because they have
Do we have some jet engines?
They have
jet.
10,000-gallon fuel tanks on site down there.
Oh, already?
From Amundsen-Scott.
That'll
Yeah,
save us some
45
money.
of them. 45 10,000-gallon fuel tanks.
Wow.
We've already got tanker ships that go down there.
Do you think we could bum some of that for our operation?
Did you know
feel we
that there's
could.
been a continuous presence in the South Pole since 1956?
Really?
Yeah.
Not Santa?
Not Santa.
Wow.
Human presence.
Wow.
Non-elves.
Interesting.
Yeah.
Interesting.
So,
Well, this
do
is...
have some jet fuel on hand.
Okay.
If you need jet fuel,
So that's how we're going to heat everybody is jet fuel. Yeah?
yeah.
Cool. Okay.
And,
Nice.
and
Nice.
you've also got you got a mechanical problem.
Oh, do we?
Yeah, because most equipment under about -40, it has a hard time. It has a little bit of a hard time.
That's fair. That's
So
fair. Yeah.
you need to allow for some downtime.
Okay.
And also, you only get 110 working days a year during the summer, the steamy Antarctic summer.
Steamy.
Yes.
It is steamy.
It is.
Bring your swimming trunks, elves.
Yeah.
You're going to be swimming. It's going to be great.
You don't even polar plunge there because you come out an ice cube.
Do you feel like we should opt in our budget for reindeer power, or should we stick with our normal equipment?
It's a good note. I think that there's some room for innovation.
I agree. I think reindeer power would be probably the most robust way of going here.
I saw Snow Dogs.
It's true.
And
Another amazing documentary.
yeah, and it would seem that animals are the most reliable way to go.
Yeah, it seems.
When your snowmobiles are freezing.
I mean, yeah, we've been doing this for a very, very long time. So we've got some jet fuel. That's good. So we're gonna need to figure out how to get materials to the job site as well. That's definitely more challenging for us. Santa sleigh, that's occupado. All right, we can't use that one. That's for the big man. So we're gonna get out a LSC 130, or SC 130, LC 130, whatever. Big plane, big freaking plane,
Large planes. that
propeller
can carry-
plane, Lockheed Martin, America. All right. I want one of those in my backyard. Yes, sir. All right.
Wouldn't fit.
It wouldn't fit, but I would find a way. All right. So anyway, yeah, we got to deliver all of this stuff. So we're gonna need to break out our shipments. Yeah, a lot of batching.
So Amundsen-Scott had 25 million pounds worth of construction equipment had to get down there, right? So 26,000 pounds of cargo per trip. Took 12 seasons to get everything down there. I'm thinking you go 10x, right? Because it was only
small.
65,000 square feet. We're building an 800,000 square foot facility. Let's scale that up.
Yeah.
Go at 250 million pounds. Distribution warehouse, Starlight and Airy.
Yeah.
Ought to be insanely easy to heat.
It's true. Warehouses are notoriously
great for heating.
For heating and cooling even. Yeah. So honestly, we don't even have to worry about that. They're so well insulated.
Yeah.
Yeah.
Thinking through those problems, it just opens up Pandora's box.
It really does, doesn't it?
Tyler, we may have a problem. Aside from the fact that you can't actually pour concrete. Did you think about that?
Really?
Yeah.
Okay.
So
was it just not set up or like what?
Right. Yeah. It's too cold. So you've got negative 57. Was it negative 57? Was that right?
I don't know.
Or am I having another Bob Hope moment? Negative 56 degrees. Sorry. Negative 56 degrees. Yeah. Concrete doesn't set up.
Okay.
So also with all that drift and the way that the ice moves and the way that snow piles up, you actually want to be able to lift the building. And you want the building to float.
Oh, shoot. Okay, so we don't have any concrete foundations.
No concrete foundation.
And then we're also going to need to figure out how to lift an 800,000 square foot structure every year by a couple inches, yeah?
Yeah, you're going to basically... Amundsen-Scott, they were able to basically lift that structure every year.
Okay.
Which extends its life.
So
Not an infinite life.
It's 30 years, yeah? 30 years on Amundsen-Scott?
30-year design life cycle, which isn't terribly long, but the first structures down there, they put them down there. They actually have just gotten buried in snow and the roofs have collapsed and they're like somewhere. This is interesting to me.
Okay.
Reminds me of like National Treasure. The
secret lies with Charlotte.
Yes.
Yeah.
And they just unearthed Charlotte from the snow.
And then they blow her up like she meant absolutely nothing.
Yeah, it's a shame.
Really a shame.
There are structures, though, for real, in Antarctica, just living under the snow.
Found a really cool pipe, though, in that movie. Anyway. The lifting of things is going to be a challenge. 800,000 square feet, lifting that up incrementally. So do we just, cut out the concrete floor? Do we just have them work on the ice? You think that's probably the best? Like almost do like just a nice little shell. Like, their elf feet can handle it.
You can put plywood down. I think you could come up with maybe a sandwiched insulated system. Maybe have a kind of sandwich plywood wall.
Hey, I think we found a use for, could we use Coffcrete? Like precast that.
You'd have to precast, but then you've got a shipping problem.
Yeah, then you do have a shipping problem.
So things to think on.
Okay.
We do need a flooring system. I do think an insulated wood option would be
Should we throw another 500 million at that? I think that should cover most of.
Way off of the pie number then, though. But yeah, let's call it 3.64.
Just for Santa's sake, let's just keep it 3.14, even though we know.
Wait, did you say 500 million?
500 million.
Another half.
Yeah, another $500,000. But no. Santa doesn't need to know that, is all I'm saying. All right. We'll just send a change order halfway through and we'll call it good. We'll blame the elves. Yeah? Sound like a plan?
Sounds like a plan.
We'll buy them off with candy canes and a lot more eggnog. And also maybe we get some beanbag chairs for them too. They're millennial elves. Beanbag chairs and ping pong tables. That'll fix it.
I'm telling you, they're eventually going to want to work from home.
Oh my goodness. So what happens
if it's true?
It's funny because it's true. Yeah, no. What happens if some of our materials get dropped and we've got to recover? Like, do we need to just have some elves on standby to go recover some of the things that Like
you may just
we
want to
miss
let
a dropped, and or do we need to just let it go?
Yeah, you may just want to let it go.
Okay, so we're
maybe let's throw another $500 million in there for cool factor.
$500 million.
Yeah, just the let it go effect.
4.1 is what we're thinking.
It seems like
we'll tell Santa 4.1.
We're not building in Norway, but there is a frozen element to this, so we'll call that the let it go portion of the budget. That's
well done.
Yeah.
Well done. Yeah, so I don't know, have we missed anything here? I think that's a pretty comprehensive plan for how we're going to get at this.
We've missed an insane amount of things if we were going to actually do this. But just for funsies, I think that's probably sufficient.
Well, let's take a look at
overbake this thing.
Amundsen-Scott, though. Like, what are some other factoids that we can pull from that? Maybe those will be good things that we could take into consideration here.
Well, okay, so fun facts about the South Pole. Did you know there's an international treaty? You do, because you read at least research.
Yes, I did.
There's an international treaty that says that the continent is only to be used for scientific research. So there's not supposed to be military activity. There's not supposed to be military exploitation of the South Pole, of Antarctica, that is.
So in the Santa Claus, that movie, he has that group of elves that were basically like the Navy SEALs. That would be illegal there, is what you're saying?
ELFS?
LFS, yes.
ELFS.
ELFS, yes.
Yeah. You couldn't arm anyone down there.
You couldn't arm elves.
Although ELFS
that security
was
issue
more
for
of
all
a
this
search and rescue group than they were militant.
Yeah, but then you're going to have some serious security concerns. So maybe we should plan on building a fence.
Here's fun, like for real. Can you imagine looking at the night sky in Antarctica?
Dude, I'd be freaking in heaven.
This would be like for astronomy and astrophysics.
Yeah. Perfect.
This is like, amazing scientific outpost. There's also something called helioseismology, which I can only surmise from the root words is basically like seismological activity of the sun. So it's basically a study of the structure and dynamics of the sun through its oscillations, like sun oscillations or like earthquake, right?
Yeah.
But they're sunquake.
It's a sunquake.
Crazy.
Knew? That's fun.
But I mean, like there are just things that you can observe there that you can't observe anywhere else. The study of neutrinos, which I'm still trying to figure out what the flip of neutrino is. Obviously,
there are billions of them passing through us every second.
Yeah, I got
that's
that
a good time.
That part I got and then wondered immediately about. Glaciology, is that right? Obviously seismology and ocean climate systems. Like there are a lot of scientific uses for a facility like that. And that's what Amundsen-Scott was for.
It's a scientific research.
Scientific outpost that we can go to and we can utilize the unique climate that we find in Antarctica. And just legit. I mean, look it up. There are some pretty solid videos online. Can we shout out the B1M?
Yeah, shout out to B1M for sure.
The B1M.
Fred,
they did a pretty cool piece on this.
Yes.
So Fred did a good job with that.
We'll try to link that in the show notes as some of these resources and stuff that Lee dug up. It's fun to dig into it and then just see how they were able to work through some of these challenges along the way. Because this isn't something that happened quickly. This was a very long process because you only had 110 working days and then you were only able to work for 15-minute increments. Yeah. It's almost like working in space in a way. There are a lot of those considerations. This is a very harsh element harsh elements that you're in.
Well, and you missing deadlines here, you miss a 110-day like construction goal.
Yeah.
You've backed up a year.
Yeah.
And you can well imagine that in an environment where everything moves around that much, there are just certain milestones you have to hit. And then there are things out of your control, like, it's negative 60 today instead of negative 40, and all of your equipment's seized up.
Yeah. So every 15-minute increment, you're out there just trying to get it unseized.
Yes, and it's just a very unpredictable environment. You've got, I mean, you think through the interview process, legitimately, all kidding aside, you do have to find a certain sort of person that wants to go down there. You have to put some really good compensation in front of them. Yeah. Then you got to make sure they understand like what they're going to live in. Mm-hmm. Like, hey, you're going to go live in there's going to be like PhDs and scientists down here, but then you're also going to have the construction side down here. There are people from the military down here. Yeah. Like, this is not an environment that you just say, oh, I can make $250K a year, being a welder.
No,
sure.
Right.
Basic process is like modularizing things and just making things happen very quickly when you get there.
Man, you think of the pre-con process they would have had to go through for some of this stuff. Like you talk about the utilization of 3D modeling of BIM.
Yeah.
Like now I don't think there's any, maybe there's some resources on how they designed this. That'd be really interesting to dig into.
Here's some fun facts. 925 delivery flights with an LC-130.
Okay.
They had one truss that they had to develop a spliced connection of just so they could fit it on the airplane into two pieces and ship. About 26,000 pounds per plane. This had this particular structure, 32 vertical columns. They excavated the snow down 6 feet, though you've got 9,000 feet of ice below and everything's shifting around, moving around. It's very fluid. They built what's called a domino pad on that floating surface. So it's basically like you're just trying to put something on the surface of the ice. You're not trying to anchor into anything per se.
Basically a counterweight in a way, like just kind of holds it down.
Gravity's kind of holding it down, but then obviously, no, you can't pour concrete.
Right.
There's a floating footing. And so they basically made that of 2x12 members that were boxed up with 3/4-inch plywood that made with like a grade beam. Like they're utilizing the steel there too. And then, they're raising the station or hope to be able to raise this station as the snow rises so that it doesn't succumb to the weight of snowdrift and snowfall.
One of the things that really caught my eye in this research was the airlock. Because if we're talking about space, there's an airlock.
Yep.
So essentially what they're doing is they're trying to mitigate the amount of heat loss. So you go in that first door, you wait, and then you go into the second door. So they're trying to provide an extra layer, a barrier there, so they're not losing a ton of heat anytime somebody opens up the door. Because, if you're in the negatives like that,
pretty big deal.
Yeah, like you're going to lose a lot of temp if you're opening the door constantly. So I think that was a really cool design move.
I think there are more things that, we call specifics of, but suffice to say, this was a complex, nuanced, and different construction process. It's been studied. There have been some good videos on it, and it's worth a look. It just kind of gets the juices flowing, the imagination going about, with enough time, energy, and money, there's some pretty amazing stuff we can do.
For sure.
And to think of something that legitimately is costing like almost $3,000 per square foot to build.
Nuts, man.
Yeah. You think about what we could build here. Or what kind of things are comparable here. I'm sure that's not the only thing that's ever run that kind of metric.
No.
Even with inflation.
Even with inflation. No, it's fun to look at, and I know we use kind of the elf and Santa thing as a little tongue in cheek here, but it's a fun way of kind of going through some of this information, and hopefully you just kind of learn something new along the way. We really enjoyed digging into this for sure, but Santa's going to have a project on his hands for sure. That's that much I know.
So it would be summer there now.
Yes.
And so that would mean that it would be staffed up with scientists. So presently there are probably around 150 people at Amundsen-Scott working. in this very real place.
Well, if you're one of them, say howdy. Shoot us an Instagram message.
Yeah.
Tell us how it is. How warm is it? Not very.
How not warm is it? Maybe you get a steamy -7 degree day. So very cool.
All right, guys. Well, there you have it. Go build something awesome.